webcams as well. So I appreciate you joining me today, and I will be delivering a lesson on very simple topic, a very simple topic in the algebra course, and this is just solving linear equations in one variable. Typically, this is after we've gotten through the pre-algebra content, this is really the first topic that most algebra courses will cover in the course. So I thought this would be a fun introductory lesson for today, and hopefully you guys will walk away with a better understanding of how to solve linear equations involving one variable. And I'm going to make the class very interactive, so I will be asking you guys to participate often, and feel free to get on your microphones and respond to any questions that I raise throughout the class period. As well, the culminating activity at the end, so we'll make some real world connections, because typically the students ask, well, how is this relevant? What are some real world applications to this? So we'll look at a few problems that are some real world applications to solving linear equations involving one variable. I'm Andre Law, by the way, and I will be your teacher for today. I appreciate you guys being on time and logging in early. And I also appreciate you enabling your webcams. And I think we're good technology-wise. I don't think we're having any uh, technical difficulties. But should you encounter any during the class, just please let me know by sending me a private message in the chat box, and we'll do our best to help you troubleshoot. I want to thank those guests that are joining us just for observational purposes. Appreciate you joining in, and hopefully, if you feel the need to jump in and participate, please feel free to do so. So I typically like to start off with a poll, just to get students uh, to think about what they know about the topic so far, and just to kind of get a sense of their prior knowledge. So I'll start with a poll today, and I'm just going to make this a short answer poll, and please enter your responses, and then we will begin. And we'll give you guys about a minute or so to respond to the poll, and then I'll broadcast the results so you can see what your colleagues have entered, and then we'll get started. Okay, a declaration of math terms. I'll read a few of the responses as we go along. Somebody entered in the Pythagorean theorem there. Okay, two values set equal to each other. That's great. Um, Two mathematical expressions are equal to each other. Just reading a few of these responses. And we'll go ahead. I think everybody's entered their response, so we'll go ahead and broadcast these results. And you guys can see what your classmates entered. Just to clarify a few things, and I know this is just our first class in algebra, but as we go deeper in algebra, we'll talk about the difference between, or the differences between, an equation and somebody mentioned formula. So we'll talk about those differences as well, and we'll also talk about how a function is different from an equation. But yeah, the standard definition is a statement that makes two expressions equivalent or equal to one another. And so whenever we have a statement of equality, it could be as simple as, and just go on the whiteboard here, it could be as simple as 3 plus 2 equals 5. This is a statement of equality, and we can prove that 3 plus 2 is actually equivalent to 5. Whenever we talk about algebraic equations, though, we're talking about a statement of equality, but we could go a step further that includes a variable. So the new term that you probably are hearing for the first time for some of you is the term variable. That term means an unknown, a quantity that we have to figure out what the value is. So I think somebody wrote that too in their admissions. We typically can write a linear equation in one variable in the form ax plus b equals c, where a, b, and c are real numbers. So who can define for me that term real number? What does that mean? And you can get on the microphone. Guys, don't be shy. What is a real number? I think we have a brave volunteer.
A real number is maybe like not something like pi or just like a real like one positive or negative number that actually has a number with it.
Right. So some parts. So real numbers, and we'll visit this again sometime, are made up of what we call rational numbers and our irrational numbers. So typically, a line is a real number. That's different from imaginary numbers, which we'll get to way deeper into the course. But for a real number, a, b, and c, this is the standard form of an equation. So if we were to represent this in numbers, you see x represents our variable or unknown, we could have something like 3x plus 2 equal 11, right? So we could see that in this case, in this form, our a would be 3, or b would be represented by 2, and our c would be represented by 11, okay? So that's the standard form of our linear equations when we include one variable. And there's another example. We have our 2x plus 3 equals to 11. And this one is not in the standard form, but we have a property that you guys should be familiar with that we could use to simplify the expression on the left. 2, and then what we have in parentheses is x minus 1. So we could use the distributive property to simplify this, and you guys should be familiar with the distributive property. So how would we simplify this expression on the left using the distributive property? See a few people are typing.
Wouldn't you'd multiply, correct? So you'd multiply 2 by x and then 2 by negative 1?
Thank you, Emily. That is correct. So with the distributive property, Parker said it as well in the chat area there. Good job, Parker. So we would take the distributor is the number on the outside of the parentheses, and we want to go ahead and multiply by the distributor by both our terms inside the parentheses. 2 times negative 1 would be negative 2, and then here we have it in our standard form, whereas a is represented 2 by 2, b would be represented by negative 2, and c would be represented by 8. And then this example on the right, we still have it in our standard form there. It's just that our a is still a real number, but it's a fraction this time, and we shouldn't be afraid of fractions, right? So our A would be represented by 1/3, or B would be represented by positive 5, and our C would be represented by -7. This is not an example of a linear equation involving one variable, because on that example we have two variables. We have an x and a y. So we have to make sure that the only ones we're going to deal with today is the linear equations involving one variable. This is not an example of a linear equation, and we'll talk about these types of equations later. These are quadratic equations, because what we'll end up with is an x squared in the expression. And anytime we have an x to the second power in any expression or in any equation, that is a quadratic, represents a quadratic relationship, which we'll get to later. All right, so any questions so far about what a linear equation is and the standard form of a linear equation? Okay. So when we talk about solving a linear equation, we want to find out the value of the variable in the equation. Okay? So we want to find out what value, what real number, what value, when substituted into that equation, makes the equation true. So looking at this equation that we started out with, 2x plus 3 equals to 11, is 3 a solution to this equation? And how do you guys know if it is or it isn't?
Oh, plug in 3 for x.
Yeah, so we want to go ahead and plug in. That's a good word. Or we could say we substitute. And so when we're substituting the value for x, we want to rewrite the expression using that value. So in this case, we're going to take the x and replace it with 3. And then we want to determine if there is equivalence between the left side and the right side of the equation. So 2 times 3 would be 6. We're using our order of operations here to simplify the expression on the left. And then we add 3 to that, and there's 9 on the left, but there's 11 on the right. So this is not equal. So we could say that 3 is not a solution to this equation. Anybody else want to try a different number to see if we could figure out the solution of x in this equation? Okay, Ray. Okay, so we're going to try 4. Okay, good. Same thing, we want to rewrite our expression, replacing the x, the variable, with the 4. And we can see there in this example, we could see that both sides of the equation are equal. And so we know our solution here would be 4. So we could always use guess and check to determine if a value is a solution to a linear equation. But sometimes that process can get a bit tedious, right? Especially when we're dealing with, you know, significantly larger numbers. We could be trying numbers forever. And so what we want to do is to take a shortcut in math. And so we learned the steps that we need to take to solve the equation rather than do a guess and check as we did earlier. Some of the properties that we use, well, one of the properties is what we call the addition property. Okay, so we know that if A is equal to B, then A plus C is equal to B plus C. And again, we're just using variables here to represent real numbers, right? and then A minus C is equal to B minus C. That means the same number, simply put, the same number can be added to or subtracted from each side of the equation without changing the solution of the equation. So let's go back to a numeric expression that we just had. So let's say we had 3 plus 7 equals 10. Okay? If we added 2 to both sides of this equation, there's still going to be equivalence, right? Now we end up with 12 and 12 on both sides. Similarly, if we go back to our original equation and we subtracted 4 on both sides, there's still equivalence. So when we add, the addition property tells us if we add or subtract the same number from both sides of the equation, it's not going to change the solution to the equation. Still will be equivalence. This is an example where we're going to use the addition property. So x minus 5 equals 12. So we would use the addition property here because if we add 5 to both sides, we'd end up with 17. Why do we use the addition property here? Because in the original equation, we have an x subtract 5. The addition property also tells us that when we add a number and its opposite, it cancels out. It sums to 0. So negative 3 plus 3 would be 0. Negative 10 plus 10 would be 0. So what we added a 5 here because we wanted to get rid of the minus 5 so we could isolate or get our variable to be on one side of the equation by itself. So we do what we call an inverse operation, okay? And so when we get rid of the negative 5 from the left, we end up with x equals 17. Similarly, the multiplication property of equation tells us that when we have an equation, if we multiply or divide by the same non-zero real number, the solution of the equation will not change. So let's just get back to a whiteboard here very quickly. Let's say we had five x equals 15. This expression on the left, 5x means 5 multiplied by x. And so we'd use the inverse operation this time, which is division. So we would divide by 5 on both sides, and that would give us a solution of x equals 3. Now, if we want to be sure that we're correct, go back and substitute the value of the variable in the original equation, and then 5 times 3 would be 15. Go back to the PowerPoint. So this time we have what's called a two-step equation, just like the form we talked about to our linear equations earlier. We have a 2x plus 7 equals 19, or A here would be 2, or B would be positive 7, and our C would be 19. The first step we want to do is to get rid of the positive 7. So we're going to use the addition property. We're going to subtract 7 from both sides, and that will leave us with 2x on the left, and then we have 19 take away 7 on the right, which is 12. So now we have a 2x equal to 12. So now we have the multiplication part of the equation. which is just 2 times x. And so we're going to use the multiplication property now to solve. And so that means we will divide by 2 on both sides, or dividing by 2 is the same as multiplying by a half, which is the reciprocal of 2. So 12 divided by 2 is 6, or 1/2 of 12 would be 6. Now if we wanted to check our solution, always do a check, a quick check. We're going to substitute 6 into the original equation, replacing the variable of x, and see if there is equivalence. So 2 times 6 is 12. 12 plus 7 is 19. Okay. Any questions so far, guys? Okay. Awesome. All right. If you guys have questions, please feel free to ask. So just to review the steps, to solve a linear equation in one variable, we want to simplify both sides of the equation. We use the addition and subtraction properties to get all variable terms. Simply put, get the variable by itself on the left-hand side and all the constant terms on the right side. Once we get them on separate sides, we want to simplify both sides of the equation. And we could do that by using the multiplication property, which is we could divide both sides of the equation by the coefficient of the variable. So this is a nice, neat, organized way to remember it step by step. So with this example, x plus 1, sure, Parker, I will absolutely go over the multiplication property. So the multiplication property tells us that if we have an expression 3 times 6 equals 18, let's say, if we multiply both sides of the equation by any non-zero number, let's say 2, we should end up with equivalence. In other words, if we do the same to both sides, we should still end up with both sides of the equation being equal to each other. Okay? So similarly, here, our original answer on both sides was 18. If we multiply both sides by 2, we would get 36. Or if we, let's say we go back to original equation and multiply both sides by another non-zero number, let's say 1/2. If we do the same thing to both sides, we're going to end up with 2 equivalent expressions. So that's what that means. Is that clearer? Is that more clear for you? Okay, awesome. Okay. So with this example, similar to one of the examples we looked at earlier, there's a part of this equation that involves another property we talked about earlier, which is the distributive property. Meaning we want to go ahead and simplify the expression on the right first by using the distributive property. So who can just remind me, what is the distributive property? How will we use it in this example? Okay, so we're going to go ahead and use the distributor. Multiply 3 by x, which is 3x, and 3 times -5, which is -15. Good. So now we have x plus 1 equals 3x minus 15. And we want to get the x on one side by itself. So we're going to bring over the 1 to the right, and we're going to do that by the addition property. So we'll subtract 1 on both sides. And so we have to watch out for negatives now, because what we'll end up with is negative 15 minus 1, which should give us negative 16. So we should end up with x equals 3x minus 16. So now we want to go ahead and carry the 3x over to the left side. So we're going to group our variable terms together. And so we'll do the addition properties as well here, except now we're going to subtract 3x from both sides. So what we'll end up with is x take away 3x, which will give us negative 2x. So now on our left side, we have an expression, variable expression, negative 2x. And on our right side, we have a negative 16. Who can tell me the last step that we need to take to solve this equation?
Divide by -2 on both sides.
Exactly. So we end up with negative 16 divided by negative 2, which will give us positive 8. Okay, any questions about this example? A little bit more complex than the ones we worked on previously. Okay. I would like you guys, even though this is a bit more difficult than the ones we've tried before, I'd like you guys to try this one on your own. And then I'm going to give you guys writing control, and I'm going to ask someone to put this solution up on the whiteboard. So I'll give you guys about 2 minutes to do this. Okay, guys, about another minute and a half. I think somebody's got a solution already. If you guys can just give me a thumbs up when you're done, or oh, there we go. A few people are done. Okay, I think a few people are still working, so we'll give them a few more seconds here to wrap things up. Okay. Okay. Okay, I think are we all done? Okay. All right. So I'm actually gonna ask Parker to put this one up on the whiteboard. And so we'll actually do a new whiteboard here, and there we go. And if you can explain your steps as well, Parker, just share whatever steps you took with the class, okay?
All right, so I'll write the problem first.
Hmm.
Actually, I'll write the second step that I took. So then I kind of cleaned it up a little bit.
Hmm.
So then I moved the x term over. So I added 2x to both sides. And then I moved the 19 over. So that brought us to 5x equals then I got rid of the 5. I did I do that right?
What do you guys think about Parker's steps? Did anyone get a different answer? Okay. So the actual solution would be x equals -6. Good job there, Parker. Did Parker do anything differently in his model than what's done in this model? Or did they solve them exactly the same way? What are your thoughts, guys?
Parker did an excellent job.
Thank you, Parker. And so our solution here is -6. And the part that we always want to make sure we do is that check. So if we substitute that -6 back into our original equation, inside parentheses, now we would have -6 plus 5, which would work out to be -1. 3 times -1 would be -3. -3 plus 4 would give us 1. Similarly, on the left, we would have 1 minus 0 with 1. So our solution would check. All right. So I want to skip ahead just in the essence of time to some real world applications. This example says the sum of 3 consecutive integers is 54. What are the 3 integers? So let's break this word problem down. What does it mean? What does that word consecutive mean? Okay, markers in a row, one behind the other. Okay, one after the other. Good. So for example, an example of 3 consecutive integers could be 2, 3, 4. Okay, or 9, 10, 11. So we know that they're each separated by 1. What don't we know in this problem? What is missing? What the
Volume.
numbers are. So what would we need to use to represent each number? Okay, X or a variable. Okay, so I'm going to use n this time just because n, number. So if our first number would be n, we wouldn't know what our second, know that it's one more than this number. So I'm going to use the n plus 1 to represent that second number. And similarly, the third number has to be 2 more than the first number. So I'm going to call that n plus 2. So our 3 consecutive integers would be n, and then n plus 1, and then n plus 2. So we're going to go ahead and write an equation that we can use to solve for n. So we know that the sum is 54. So we're going to write an expression using the sum of these 3 expressions. N plus 1 plus n plus 2 equals 54. So there's our linear equation. Simplified, we can see there's an n plus another n plus another n. So that's going to give us 3n. And then our numbers 1 and 2 would make 3. So our expression then would be 3n plus 3 equals 54. So now we have it in a regular form or standard form for a linear equation. We want to go ahead and use the addition property first. And so we'd minus 3 on both sides. And then that would give us 3n equals 51. I want to go ahead now and then use the multiplication property and divide by 3 on both sides. And that would give us n equals 17. Any questions on this? Okay. So if we know the n, which is 17, is our first number, then we can automatically know that the second number will be 18, and then our third number would be 19. 17, 18, 19, those are consecutive. Now we want to check to see if 17 plus 18 plus 19 actually gives us the sum of 54, which is what we were given in the original problem. If that works, then we know we found the right answer. And so we do a check. 17 plus 18 plus 19 is in fact equal to 54. So we've got a check. Thumbs up on that. Okay. I want you guys to think about this problem and then think about how you would set this up in a linear equation and then how you would solve this in a linear equation. This is another real world problem here. We know we all rent cars at some time, at some point in our lives. Say Jenny's got an equation ready. Okay, Jenny, you want to tell us how you came up with that equation?
So the $25 is the fixed cost,
Mm-hmm.
and Anna is charged 50 cents for each mile she traveled. So it'll be, X would be the mile she traveled. So it'll be 0.5x plus 25, because that's a constant. And the total cost was $55. So 55 would be on the other side of the equation.
Did anybody get a different equation than Jenny's? Okay. Emily, you want to show us how you would go about solving this equation? So the number of miles, we don't know how many miles, right? So that has to be the variable. So good job there. So how could we figure out the number of miles given the equation that we've now written? Okay. Ray, do you want to jump in here and help Emily out with solving this problem?
Sure. Yes.
Thank you.
So the way that I did it is I basically followed that same equation that Jenny used, and so I ended up moving the 25 that was on the left-hand side, and I subtracted that from 55, and so I ended up at 30. Um, I then divided the point half, sorry, the point 5, um, moved it on the other side, and I ended up with 60 as my answer, 60
Okay.
miles.
And then 30 divided by zero point 0.5 is 60. How can we
Yep.
check to see if our solution is accurate? What can we do here to check to make sure that she did in fact travel 60 miles and we didn't make a mistake somewhere?
Immediately, I plugged that number, I plugged the 60 into my original equation, and it came out to 55. So I'm confident Anna traveled 60 miles.
Okay. Awesome. So if we get a statement of equality, then we know we're correct. So 0.5 times 30 times 60 is 30, and then 25 plus 30 is in fact equal to 55. Good job, guys. All right. So we're gonna do, in one or two more examples. Just gonna put this one up on the whiteboard here.
I think I still have control of the whiteboard.
No, I still have it. I just have to input it and then you guys will see it. Okay. All right. So Red Cab Service charges $4 as a flat fee, 25 cents for each mile traveled. If Josh takes a cab to his grandmother's house and the cab charges him $11.50, how many miles did he travel? Okay, I can give you guys about another 30 seconds or so. Okay, any volunteers? Okay. Alrighty, so our equation should be 4 plus 0.25 x or m. Doesn't matter what variable you use, right? And then 1150.
X is 30.
And then we want to subtract 4 on both sides with the addition property. That's going to give us 0.25x equals $7.50 or 7.5. And then we use the multiplication property here to divide by 0.25, which is the same as multiplying by 4. And so x would be 30. Awesome. All right. So what I would like to do now, awesome, Ray. Good job. What I would like you guys to do now is just to think about what did you learn today? What do you still have questions about? Okay, so what did you learn today? What do you still have questions about? And what ideas do you still find to be challenging? So if I could get a few people to talk about, I know Parker entered in a response there. Okay, Parker, good job. Would you like to share that on the microphone, Parker?
Sure. I liked how different some of the different properties were brought together to solve a problem, and sometimes the problem
That's
looked really
really true. Sometimes
difficult
you
at
look at a
first,
problem, right, guys, and it
but
looks
breaking it down into
almost
steps and
overwhelming,
kind of
but
going,
the minute you
handling
start to
each issue
put
one
the
at a
steps in
time,
place that you
you
learn, step
eventually
by
arrived at
step,
an answer.
you
And
break that
I liked
complex
that
problem into
daunting task
simpler
at
steps.
first, made easier by taking steps.
Jenny, and you guys could share also anything you still have questions about. I don't think you guys will find anything challenging because I've done such an amazing job today that no, just kidding. But certainly you could share anything that you still have questions about or anything that you'll find challenging.
Yeah.
Okay. Ray,
No, everything was explained very thoroughly and clearly. And just
Um, for me, it was really interesting to kind of, really think
yeah,
about the
these are a lot
consecutive
of these
numbers
consecutive number
and how
problems are
that's a
very
super easy way
common
to figure it
in
out.
algebra
So if
because
ever
you
I get
could
into a
really
problem like
usually
that,
write an equation to
every now and
represent
then
or
people give
figure
you
it out.
riddles or, you talk about
And
a number
Marcus,
equaling another. I have an equation that I can use to put it all together.